Module 3, Session 3. Session 3 will cover mixed geometry problems and teaching tips. Subject Outcome 3.2, Mixed Geometry Problems and Teaching Tips. Welcome back. Now we have covered the geometry of straight lines, angles, and triangles, and we have worked through the circle theorems, the cyclic quadrilateral theorems, and the theorems involving tangents. Let's listen to a senior lecturer discussing his approach to circle geometry.
So first, equip yourself with all the theorems. Make sure you can see it within a diagram. And then obviously, then you look at certain keywords. Diameter. What's diameter? Diameter divides a circle into two halves. What's diameter? Diameter also subtends an angle of 90 degrees. Tangent. Diameter is perpendicular to tangent. And so we can carry on. Circles, 4 groups. There are 4 groups of theorems that relates to circle. And if you think about it, I normally group it as follows. You have the center groups, dealing with the center angles. And even the diameter, because that also goes through the center. Then you have the non-center. That's those ones that are subtended by the same line. Then you have the cyclic quads, opposite interior angle, supplementary exterior opposite interior angle. And lastly, you have the tangent. And that sums up, in short, all the theorems that relates to the circle. And that is what geometry is all about in a nutshell.
In this session, we will look at how we bring everything we have learned together. We will revise how to approach geometry problems, and we will also work through some mixed examples. Here, a senior lecturer explains how students should approach geometry problems.
For geometry, it's very interesting because the analysis of the given information already answers the question. In other words, you always start with the given information and why. And as you move on, why, with the knowledge at the back of your mind and the application of the theorems, later on you've answered all the questions without even looking at the question. And once you've answered all the whys, you've already answered the question.
Students struggle to identify what to use where in geometry. So to summarize, when faced with a geometry problem, we always start with what has been given. Information is always given for a reason. We ask, why have we been given this information? It can also be helpful to work from the inside out. Always look for key information. For example, if we are told there is a center, look for radii. If we have a radius, what does that mean further? We see a tangent, what does that imply? Is there a cyclic quadrilateral? What does that tell us? And so on. Let's go straight into an activity. This activity has 3 parts. For question 1, in pairs, test each other on all the circle theorems as you would in class. For example, ask your partner, give me the theorems about tangents. Question 2 and question 3. Start working through the problems based on the diagrams, thinking about how you would help your students with them. Now let's watch some lecturers working through the solutions to question 2 and 3.
Let's look at this diagram that we have in front of us here. We see they've given us an angle of 20 degrees. And now we read further what extra information is provided. By looking, they say TAD, in other words, TAD. It's that angle there, that whole angle there, the 20 included, TAD. That is equal to 160 degrees. It means that this angle as well as that one as well as the other one must add up to 160 degrees. Immediately, there's an adjacent angle which is DAN or NAD. NAD plus TAD must give me 180 degrees. Therefore, I can immediately find the value of DAN, which will be equal to 20 degrees. So that is adjacent supplementary angles. And we all can see that this TAN is a tangent, not because it's labeled like tan, no. Tangent is it touches the circle. In other words, now you're going to say tangent AN and then chord AD, and you can see that this angle G here, the small one here, is subtended by that chord. So that one will also be 20 degrees. Immediately complete now this triangle. If this is 20 plus another 20, then obviously that angle there should give us 140 degrees, because that is the interior angles of triangle ABD. Now we look further. You see this is a tangent. That is the diameter because it goes through the origin, which means this angle here will be equal to 90 degrees. And now we need to add, if 90, 20, that is obviously 110. 90 plus 20, it's 110. Obviously, that angle there will be equal to 50 degrees. Now just test it. It's 90 plus 70, and that must add up to my 160 degrees. Considering this is the diameter, and you can all agree that that angle is subtended by the diameter, which means this angle here should be equal to 90 degrees. Because there's my diameter, it subtended that one. And then immediately completing this triangle here, this angle number 2, 90 plus 50 is equal to 140, and then that angle there will be equal to 40, because that's the internal angles, and that gives me 180 degrees. And now I'm going to look at, they said the magnitude of each numbered angle. Number 1 I've answered. Number 4 I can calculate. Number 3 I've answered. And number 2, now I'm just going to focus on putting it into a structured form. So let's start where we've started off. We have first calculated angle DAN. Is that correct? So let's say DAN, because based on that 160, we first calculated DAN. So you're going to say DAN, angle DAN is equal to 180 minus 160, and that is equal to 20 degrees. That is adjacent supplementary angles. Immediately after that, I can then calculate angle ABD. I can then calculate angle ABD. ABD, because tangent chord is equal to 20 degrees. That is tan chord theorem. And then immediately from there, I can now calculate D3. D3 will be equal to 180 minus 20 degrees minus 20 degrees, and that is equal to 140 degrees. That's the interior angles of triangle. Interior angles of triangle ABD. have calculated D3. Once I got D3, I can now go to my diameter, because that's exactly what I've done. My diameter, obviously, CAT or TAC. TAC is equal to 90 degrees. Diameter perpendicular to tangent. Perpendicular to tangent. And then immediately now I can calculate A1. A1 will be then equal to 160 minus 90 minus 20, and that is equal to 50 degrees. After I've calculated A1, I've got now D3, I got A1, so obviously now I can now calculate ABC. ABC is equal to 90 degrees. Angle in semicircle. So now from there, I can calculate the value of B4 is equal to 90 plus 20, and that is equal to 110 degrees. And now inside that triangle, I can now calculate C2 also. C2 will be equal to 180 degrees minus bracket 90 plus 50, and the C2 will be equal to 40 degrees. Internal angles of triangle ABC. And this is triangle ABC. Let's just double check that I calculate all angles. A1, I've calculated A1 as 50. B4, I've calculated B4 as 110 because it's 90 plus 20. C2, I've calculated C2 as 40. And obviously D3, I've calculated D3 as 140. And you can clearly see there, based on the information at hand, there's no need to solve it in sequence as long as you answer the question and you answered all the different numbered angles. Let's consider the following diagram. And let's look at the information that is provided that are linked to this diagram. The first statement, they say there, AB is a tangent to the circle. We stop there with center O. We have the tangent AB, the chord AC, and you will see there the angle of X is subtended by that chord. In other words, from that we can deduce that this angle here will be equal to X. Now let's write it down straight away because they want 5 angles that are equal to X. So we're going to say firstly, A3 is equal to X. Why? Tangent AB, chord AC theorem. Tangent chord theorem. Right, we have one angle already. Now let's read further. BCOD is a straight line. Okay, the only thing we can deduce from that is we have on a straight line, these 3 are adjacent supplementary angles. But now we look at AE. AE is in parallel with BD, obviously. BD. I think now it makes sense why they were saying it's a straight line. Now, when we're looking at parallel lines, we all know it means fun. So we're going to look now at corresponding angles. We're also going to look at alternate angles. And then we're going to look at co-interior angles. But co-interior angles is out because we don't need angles that adds up to 180 degrees. If you look at AE in parallel with BD, then you will agree with me that this angle here, this one will be equal to X. You can see they're alternate angles. So we can say A1 is also equal to X. That's the second one. A1 is also equal to X. And what is that? We first need to state because AE, remember what I said earlier on, is in parallel with BD, that's alternate angles, ALT angles. Right. Now if you look at A1 and you look at that arc there, can you see there? That arc subtends A1, but the same arc subtends C1. So you will agree with me that C1 will also be equal to X. Arc DE subtends A1, but the same arc subtends C1. So C1 will also be equal to X. Angles subtended by DE. Right. Now we are here. Being that the center point, it means that this is a radius as well as that is a radius. And if these two are radiuses, it means that triangle OEC is a isosceles triangle. That means E2, the base angles, will be equal. So E2 will also be equal to X. So we're going to say E2 is equal to X. And why is E2 equals to X? Because of the fact that, and you can even see it from here if you look at it from this angle, which makes it very interesting. It's also subtended by, I will come to that now, the next one, but you can see there that E2 is equal to X because of that isosceles triangle. OE equals to OC, and that equals to radii. We use the word radii. That means we're referring to radiuses. And because of that, that makes of OEC a isosceles triangle. Then the last one, if you look at it from this side, this arc here, or this chord AC, you can see subtend that angle as well as E1. So E1 is also equal to X, and that's angles that are subtended by the same chord AC. Angles subtended by chord AC. These are the 5 angles, A3, A1, C1, E2, and E1. Those 5 angles on the diagram are equal to X.
For our final geometry activity, work in pairs to solve these 2 questions based on their diagrams. See how you can apply the teaching tips as you solve these geometry problems. Here's a video showing a lecturer working through the solution to question 1. The solution to question 2 will be provided by your facilitator.
If angle B is equal to 15 degrees, which is formed by ABO, so we're focusing at angle B here, is equal to 15 degrees, determine the magnitude of BAO. So we want the magnitude of angle A. Now it is worth it to note that O is the origin. Thus, the length of, if you're looking at triangle, so you're looking at triangle, that's for number A, looking at triangle AOB. If you look at this triangle, you would note that AO is equal to BO, which means that this is equal to that. And they are joined by a common line, AB. So they are joined by the common line AB, which therefore makes it easy for us to understand that angle B is equal to angle A. And then of course the reason is that this is an isosceles triangle. This is an isosceles triangle. That is very clear. Now, with that being said, angle B is equal to 15 degrees. Therefore, angle A is also equal to 15 degrees for number A. Is equal to 15 degrees. We found number A. Let's go to number B. Now what do we need to do? We need to find the magnitude of AOP, not BP, focusing at angle O. So we're looking at AOP. So we want, in other words, we want to see angle number 2. We want to find the magnitude of angle number 2. It is clear for us to understand that angle AOB is equal to 180 minus 30 degrees. Why 30 degrees? Because this is 15, that is 15, which means that this angle will be 150 degrees. But this is just angle AOB, which is going to help us to get to this angle. So we know the magnitude of this angle. Now we need to know the magnitude of that angle, but we still need to work with that other angle. And this reason, if necessary, angles in a triangle sum up to 180. That's the reason. This number B further on says that 2 times angle 2 is equal to 150. So 2 times angle 2, which is equal to 150. What does it mean? It means that angle 2 is equal to 150 degrees divided by 2. That's making our answer to be 75 degrees. So angle 2, which in actual sense is equal to angle O at AOP, is equal to 75. Let's look at number C. Number C, we want to find the magnitude of APO. So we're looking at APO. So we want to find angle 3. APO, which is also equal to angle 3. What we know about this is that interior angles of a triangle sum up to 180. What we know is that interior angles of a triangle sum up to 180. That's meaning that this further on states that angle 3 plus angle 2 plus 90 degrees, it should be equal to 180 degrees. Reason, angles in a triangle. sum up to 180 degrees. This further on then makes 3 to be the subject of the formula, angle 3 to be the subject of the formula, which means that angle 3 will be equal to 180 degrees minus 90 degrees minus angle 2, which we've previously found to be 75. With the aid of our calculator, we get our answer to be 15 degrees. So angle 3, which is also equal to APO, is equal to 15 degrees. What do we need now? We need to find the size of the length AP. We need to find the size of this. So you can see that this is a right angle, which makes it to be able to use the cosine rule. We can find that AP is equal to cos 15 degrees, which is this angle of angle 3, multiplied by 120, which is this length here. Because cos, by the way, the trig ratio here, the cos, this is just a by the way statement, adjacent over the hypotenuse. That's your cos x. Cos x is equal to adjacent, which is 120, over the hypotenuse, which is AP. So this comes from that. Of course, we should have known that by now. Then, which means that your AP then will be equal to 120. It will be equal to cos 15 degrees times 120 degrees. 120 the length, which is 115.91 millimeters, because your units are given millimeters, which should then make it clear for us to understand. Number E, find the length of BP. This other side, I want to find the length of BP. You will see that AP and BP are formed by equal lines. So AP is equal to BP. Which makes it equal to 115.91 millimeters. We have solved questions number A to number E.
This finally brings us to the end of the geometry section. Thank you for your participation and concentration. See you in the next module, Trigonometry.